Okay, now we start from here. Start from here. Okay, about the shear, now we will know this is the same load. But the apply area, I mean this is the apply area. Apply plane. If apply plane here and the apply plane here. Apply plane here, we will induce compressive stress. If apply here, will become shear stress. So the conclusion is the same load different apply action, different applied plane, and then we will get different stress. For example, in this case, compression. We mean actual stress is equal to the loading and then divided by the area A. And the area A and the shear stress should be equal to the same loading but divided by area B. So it's very clear. It's very clear that the actual compression stress or shear stress or even the same loading, even the same load, the same loading, but a different plane. The plane here and the shear the plane here. So different plane induce different stress, even the same loading. Let's continue to solve the problem here. Equal to see the same loading, and the area A here is we know is a quarter pi d squared, but the area here should be is the surrounding of the hole. We say is a pi d is a surrounding of the hole, and multiple the thickness. So according to the calculation, you can calculate by yourself. And I directly give you the answer because you can calculate by yourself. So the answer is so we know is 110. Yeah, you may know it's a 110. And divided by pi. Square divided by 4. So it's equal to 350 MPa. And for the shear, it's 110. Sorry. It's 110 and divided by the area according to calculation. The thickness here is about 8 millimeter. So finally we get the answer is 119 megapart. So please calculate by yourself. Calculate by yourself. Okay, that's good. And we finish all shear stress, compression stress, any kind of stress. And now we are going to another topic about the design. This is the final of the chapter. The most important is how to design a structure. Maybe we can look. Maybe we can look. We can look the video first. You see, this bridge I already showed you before. And when the car pass through and collapse. Yeah, from the movie, for you, a student in civil engineering or mechanical engineering, it's very important to design a bridge never fall down, because it is a problem of safety. And we are engineers. We have the duty to design a reliable bridge for the human beings. So in this case, we have 3 important items. One is allowable stress, maximum load, and a minimum area. That means we can look again. Yeah, when the car come here, no problem. Yeah, you will start the start fair here. Start from the brick here, brick. That means the cable here should be the loading should be exceeds the value. So in this case, we need to consider many questions about this. Hold on. When we design the cable here, you should be very important for engineer is a factor of safety. The definition of the factor of safety is the actual strength divided by required strength. That means the strength here, maybe you need 100 megapart is required, but you can actually sometimes is only 80. Yeah, so the factor of the safety is required strength. Most of the time the actual strength is higher than the required, because you need to put 1.2 or 1.5. So when you do the design, you put more to guarantee you are is a safety. For example, in this case, it only needs 100 megapart, but you can design 125 megapart to ensure every time is a safety. I repeat again, the strength here maybe only you need 100 megapart, but you can design for 125 megapart, so you can guarantee most of the time is a safety. So the factor of safety is the actual strength and divided by the required strength. If you put the 1.25, that means you are over design, but it should be safety because it's only need 100, but it deny 125. So it's the most important for you on the design. You need to put some safety here to over design. And also, what is the allowable stress? The allowable stress is the yielding stress divided the safety. I mean, if you put 1.25, and that means your allowable stress is should be lower because you can guarantee most of the car cannot overload. So for you put a 1.25 here, and in the original strength is maybe 100, so you will divide it by the factor, so should become lower. So most of the car should not exceed the load. For example, the car is 1,000 tons, and you will have a regulation say 100 ton is too high. You need to reduce to maybe 60 tons. So this is the meaning of allowable stress. So that means the allowable stress is lower than the real stress because you have some regulation that the car not so heavy. So allowable stress is the actual material yield strength divided by a factor. So you will let the allowable stress become lower to guarantee its safety. So the allowable stress is like this, divided by the safety factor. Okay, when we talking about the allowable stress, what is the relationship about the maximum load? Also, we call allowable load. The allowable load from the equilibrium equation, the allowable load is allowable stress multiplied by area directly. That's a allowable load, allowable stress multiplied by area. How about the minima area? Because the minima area is area we can bear the loading. So it's the maximum load divided by allowed stress. So the area should not be so small. The more the area, and the lower the load, and the smaller the area should be the higher the loading. So we cannot let the area too small. So we have a minimum area. Remember, if the area too small, and then should be you cannot take more loading. So we have a minimum area limitation. Okay. Yeah. Okay. So we are going to another topic about the design. For example, this is a typical design idea. We say it's a design. application. In this case, this is a 2-bar steel bar, and this is the 2-bar and the hand plate here. It's we are very applicable. When you are an engineer, you will meet this kind of design. 2-bar hand plate. And then we will calculate what is the you can see, and we will determine the required cross section here. You know, if the cross section too small, should be brick. I mean, you need a guarantee. That means, sorry. We will calculate minimum area here. Minimum area here to guarantee no collapse. Okay, we should another from the also the minimum bolt area. The idea is if the bar too thin, that means the area too small, should be collapsed. Maybe will collapse here, And if the hole here is if the bolt here too small, maybe brick here. So in the design application, we need to calculate what is the minimum area here, and also the minimum area of the bolt here to guarantee the structure is stable. We take a rest and then keep going.